This is the first in a series of lectures in which we'll do a careful walkthrough of an example JS program that plays a text version of the game Mastermind. Now, for preliminary reading here, pause the lecture and look up Mastermind online if you're unfamiliar with it, and be sure you understand its rules. There are a myriad of sites that will explain them to you. We're looking at a 4-color, generally, pattern matching game. And then coming back from what may have been a pause while you looked all that up to make sure you remember the Mastermind rules. In lecture question 1 here, based on that preliminary reading, and assuming we use letters instead of colors as the elements of the pattern, how many exact and inexact matches will result if I make a guess of A, B, C against a hidden pattern of C, A, C, B? And those are both in the transcript, by the way, if you didn't catch them verbally. Coming back from thinking that through, the answer you should come up with is that there's one exact match, the A's in the second position, and then there are 2 inexact matches, one pair of C's and one of B's. The second C in the hidden pattern cannot be matched, nor can the second A in the guess, because any potential partners have already been used up in another match, and no one letter may participate in 2 matches. So, assuming we now understand how Mastermind works, so far, let's talk a little bit about running a JS program. So far, we've done interactive JS statements, but to create a JS program, you write JS into a text file, and you name it with a JS suffix, typically. Our JS Mastermind program is broken into 4 such files, of which mmind.js, which you can see on the slide here, is the main, and the one we'll start with. For most JS shells, you run a JS program by using the file name as a command line argument to the JS shell command, e.g. js mmind.js. In a browser, you'd run it by including it in an HTML page via a script tag. As mentioned in the intro lecture, there is no need to compile a JS file. It's already ready to run. So the development cycle is edit the JS file, save it, often without leaving the editor, and then run it from the command line or browser. It's a very fast loop, and one of the nicer aspects of interpreted languages, as we said earlier. Now, let's start then by running the Mastermind program so we know what it does before we look at the JS code that does it. I'm using the JSDB shell, so I'll type JSDB mmind.js, which, as you can see in the directory listing above there, is one of my files, and I'll get back a prompt here. The program uses patterns of letters, like we said, not colors, as the traditional Mastermind game does, and you may choose the number of letters in the pattern and what the highest possible letter will be. The lowest is always A. The program starts by prompting you for these 2 data. So let's try maybe F and 4. So we'll have patterns of 4 letters, each between A and F, inclusive. Now, immediately, though, you can see a printout here of parameters. That's a debugging print. Just note it for the time being, and we'll get back to it when we talk in more detail about the code. It's dumping out some internal data from the program. Now, we're going to score each game by the number of guesses that you need to get the hidden pattern. And one program session may encompass multiple games. You get to start a new one each time you finish the present one. The program will track your average score across all games. So the program repeatedly reports your current average, or NA, not available, for the first time, and asks if you want to play a game, as you can see here on this line right there. If you respond with a Y, capital or lowercase, then it selects a hidden pattern and immediately prints it out to make it easy to guess. We don't actually want to spend a lot of time playing Mastermind here. It then repeatedly asks you for guesses, doing appropriate error checking until you give a guess with the right number of letters, each within the specified range. Each guess must have blanks between the letters as well. Let's enter a few invalid guesses here just to see how that works. So I'll try F, A, B, F, D. Obviously one letter too many. And the guess is too long. A, B, it does permit lowercase, by the way. C, D, or just C. Yeah, that guess is too short. So let's see here. We might try something that is not a valid guess. Yeah, and it's also too short. There's only one thing there, not four. So that's the idea there. And I'll stop playing around here and actually enter a valid guess. When you do give a valid guess, it then computes and reports the number of exact and inexact matches and asks you for more guesses until you match the hidden pattern. So maybe I'll do a F, C, C, E here. And we got 2 exact and 2 inexact there. Or maybe I'll do a E, E, C, F. And we got 0 exact and 3 inexact, all as we should here. And then let's enter in the secret pattern, FCEC, and reports 4 exact and the current average, 3.0 guesses, as you can see. And we are asked if we want to play another game. I'll end the program here by refusing that other game, and we can then proceed on with the lecture. So with all these preliminaries out of the way, let's now look at the mmine.js source code. Make that a little larger there for you. A brief note here also before we start. For minor syntax issues, like the need to add var before a variable declaration, or terminating lines with semicolons, or the organization of a for loop header, I'll expect you to rely on the Reintroduction to JS page, or related material, including your prior knowledge of often identical Java or C syntax. These lectures are about the deeper ideas, not all the little semicolons. So let's start with the big idea here that a JS program has no main function per se. Execution just starts up at the top of the file with the first line of source and kind of proceeds from there downward. You can write a whole JS program with no functions at all. Just a series of variable declarations and JS statements outside of any function, rather like a scripting session. Unless you're just hacking around, though, or are a beginning programmer, you put your JS code into functions and then run the functions. And you can pick what function you want to run as the main, as we'll see in a bit. Let's skip the first several source lines for now and start with line 8 down here. Now, as you can know from past lectures reading, that's an anonymous function declaration or definition with no parameters. The function's body is in braces from line 8 down to line 32, or 33 actually, sorry. Now, the preliminary reading generally showed you functions with names. Like a name might appear right here between the function and the parentheses, maybe function add or some such. Our function has no name. And except in rare cases, we will never name our functions directly, preferring instead an anonymous function definition and assigning the result into a variable like mmind, as we do here. Right? Understanding what this does involves a critical point about JS functions. They are objects, unlike functions in either Java or C, and they can be dynamically created and then referred to by a variable. You should view line 8's function definition as creating a function object and returning a reference to it, which reference goes into the variable, or the reference, mmind, as our diagram here will show. Thus, the picture you have here should always, or the picture we've drawn here, is something you should always keep in mind when dealing with JS functions. The anonymous declaration is like a new function call that dynamically allocates a function object. And while a function object always has code as one of its member data, so to speak, in later lectures we'll also attach other member data or properties to function objects. So we can have other stuff too in here. Indeed, a function object may have references to other functions added to it as properties. But Don't let that boggle you just yet. We'll look at it later. For now, let's just get used to the idea that functions are a sort of data with reference variables pointing to them. They can be passed as parameters to other functions, arranged in arrays, etc. As we get more sophisticated, we'll pass or assign function references around like any other variable. And indeed, this ability is one of JS's most powerful features. For now, we'll just set up a global variable, though, to point to each function we create and use that variable to reach the function. JS, by the way, has a lot of references to objects, function or otherwise, and we need a term for the thing the reference points to. Let's use target for this. So we might refer to that anonymous function here as mmines target, and we could speak of calling mmines target. We'll use that terminology for the rest of this segment, but in later segments we'll just speak of calling mmind, since that's simpler, even if it's not exactly correct, since mmind is just the reference, not the function. So after setting up the function object on lines 8 through 33, we're left with just line 35 down here, which calls mmines target. Following a function reference with parentheses, perhaps containing parameters, is understood to mean call the reference's target, not the reference itself. This is how we get mmines target to be the main program. We explicitly call it once it's set up. Here's an in-lecture question for you. What do you think would have happened if we had omitted line 35? Make your best guess. And coming back from a pause there. If you guessed that the program would have ended without running anything, you got it right. The JS interpreter would have said, in effect, wow, look, you set up a reference to that nice long function object, and then you never used it. Too bad. No matter how many functions you set up, you still need an outside the function top-level call, like line 35, to start the program. But a good JS program has only one such call, and all the other code is in functions.